In this video, we're going to look at using an nth term formula, this position to term rule, to help us decide whether a particular number is actually a term of the sequence. So let's say we've got a sequence where the nth term is 7n minus 2, and we want to decide whether 40 is a term in this sequence or not. Well, we can do this a slow way, and we can do this a better way. Let's start off with the slow way. The slow way would be to just start listing out the terms of the sequence. So the first term would be 7 times 1 minus 2, so 7 times 1 is 7, subtract that 2, and that gives me 5. The next term would be 7 times 2, which is 14, and subtract the 2, and that would give me 12. And hopefully you remember from the previous video that because we've got a 7 here as our coefficient of the n, this sequence is going to go up in steps of 7. So I could just keep on adding 7 like this. And look, here we are, we've got the number 40. So 40 is a term in this sequence. But this is quite a long-winded way of going about it, especially if instead of looking to see whether 40 was a term in this sequence, imagine the question said, is the number 420 going to be a term in this sequence, or some really large number? We wouldn't want to list out the sequence going all the way up to some really large number. That would be a lot of work. So let's see if we can do this a different way. What we're going to do is set up an equation and solve it to see if 40 is going to be in the sequence. Now, if 40 is going to be in the sequence, that means there is some value of n where when we plug that value of n in, 7n minus 2 ends up being 40. But it's not just any old value of n that we can have. That value of n must be a positive whole number because we're only dealing with the first, the second, the third, the fourth, the fifth, the sixth, and so on terms of a sequence. We don't really have something like the 2.5th term of a sequence. That doesn't really make sense. So let's set up the equation. If 40 is a term in this sequence, then for that particular term number, whether it's the 7th, the 8th, the 100th, 7n minus 2 must equal 40. And this is an equation that we can now solve. I can add 2 to the left-hand side and the right-hand side. That would give me 7n equals 42. And I can now divide the left-hand side and the right-hand side by 7 to just give me n equals 6. Now, because I've got a nice whole number as my answer, I know that 40 is in the sequence. And the nice thing about doing this is that not only do I know it's in the sequence, I know it's the 6th term of the sequence. It's when n is 6. And we can just test that. When n is 6, let's substitute that in. 7 times 6 is 42. Subtract the 2, that's 40. Yes, 40 is in the sequence. And not only that, I know it is the 6th term. Right, here's the second example. Now, just like before, I could do this by listing out the first few terms in the sequence until I get past 40 and check whether the number 40 actually is one of the terms in the sequence. But that's not really a good strategy. Remember, imagine we were looking for whether a really big number was a term in that sequence. It would be a lot of effort to list out enough terms of the sequence to check whether that really big number was in there. So let's do this by setting up an equation again. If 40 is in the sequence, then 5n plus 9 must equal 40 for some value of n that is a whole number, a positive whole number. So let's try and solve the equation. I'm going to subtract 9 off the left-hand side, and that would leave me with 5n. Now, to keep this equation balanced, I've got to subtract 9 off the right-hand side. 40 minus 9 is 31. Now, to get to n, I need to divide this by 5. So I need to divide this by 5. 31 divided by 5 is just 31/5. Now, this is not a positive integer. And that means that 40 is not a term in the sequence. So the answer is no. Let's just do a quick check to make sure that makes sense. If we did list out the first few terms in this sequence, we would get, well, we substitute 1 first. 5 times 1 is 5, plus 9, that's 14. The next term would be 19 Remember, this is going to go up in steps of 5. So then we'd have 24, 29, 34, 39, and 44. Now, you'll see that 40 is not in the sequence. But if it did exist in the sequence, it would be somewhere between the 6th and the 7th terms. We've got the 1st, 2nd, 3rd, 4th, 5th, 6th, and there's the 7th. 40, if it could exist, would be the 6th and 1/5 term. But that doesn't really make sense. We can only have a 6th or a 7th term and not something in between. So therefore, 40 is not a term in the sequence, which we know because our value of n that solves this equation is not a positive integer. Here's the third example. Pause the video and have a go at this one for yourself. Be careful with the negative there. Okay, if 40 is a term in this sequence, that means we could solve this equation and find a value of n that is a whole number. Let's see if that's what happens. What I'll do first is subtract 50 off the left-hand side, and that would leave me with negative 2n. To keep the equation balanced, I'd have to subtract 50 off the right-hand side, and that would give me negative 10. Now I could divide both sides by negative 2, and that would give me n equals 5. Now that is a positive whole number, so yes, 40 is in the sequence, and in fact it is going to be the 5th term. The 5th term because we're looking at when n is 5. So if we substitute 5 into there, we see it's the 5th term, 5 into here, negative 2 times 5 is negative 10, negative 10 plus 50 is 40. So yes, 40 is in this sequence. Here's another example for you. Again, we've got a negative there, so be very careful. Pause the video and have a go at this one. Okay, let's go ahead and set up the equation. If 40 is a term in this sequence, then negative 6n plus 100 must equal 40 for some value of n that is a positive integer. Solving this equation, we get negative 6n equals negative 60, which means n equals 10. Now 10 is a positive integer, and that means that yes, 40 is a term in this sequence, and in fact, it is the 10th term in the sequence. Here's the final example. Pause the video and have a go at this one for yourself. Right, here's the answer. If we set up the equation, 3n minus 16 equals 40, we can add 16 to the left and the right hand side to get 3n equals 56. Now, the solution would be n equals 56 over 3. Now that is not a whole number. That doesn't simplify to a whole number. So 40 is not going to be a term in this sequence.